Hello everyone, welcome back to our channel. In this video, we'll be discussing about the third problem of today's biweekly contest, Bitwise XOR of all pairings. The problem states that you are given two array nums1 and nums2, each consisting of non-negative integers, and there exists like you have to form third array nums3, which consists of bitwise XOR of all pairings of integers in nums1 and nums2. And finally, you have to return the bitwise XOR of all integers in nums3. So let's take an example. Let's say the nums1 is this and nums2 is this. Now you have to form nums3, right? So first you will do bitwise XOR of 2 and 10. You will be getting 8. Now you will do bitwise XOR of 2 and 2. You will be getting 0. Now you do bitwise XOR of 2 and 5, which is 7. And similarly, you could do bitwise XOR of 2 and 0, which will be 2. So you get these four elements by doing bitwise XOR of 2 with every element of nums2. Similarly, you will do bitwise XOR of 1 with every element of nums2. And then you will do bitwise XOR of 3 with every element of nums3. And that's how you will form the nums3 array. Now, once you have nums3 array, the problem states that you have to return the bitwise XOR of all the elements of nums3. So bitwise XOR of this array, all the elements of this array would be the answer. So hope the question is clear. Now, because we can't apply brute force simply here because we can't generate the array nums3. The reason being nums3, generating nums3 would take order of length of nums1 into length of nums2 complexity, which will be very used because nums1 and nums2 length both are in the order of 10 to the power 5. So we can't do this. So how to solve this? So just like addition and subtraction, XOR also follow this property. Basically, if you do XOR of x and y and XOR it with the result z, XOR the result with z, the result will be equal to if you do XOR of y and z and XOR the result with x. So basically, bracket doesn't matter. You can remove the brackets and just do XORs. And you can put bracket anywhere. So you can put bracket here, you can put bracket here, or you can just take x and z and put bracket like x or z in one piece and y in another piece. Okay, so that basically you can open the brackets and just group elements together. The answer would be same. So having this property, how can we solve this? So remember what we have to do. We have to XOR every element of nums1 with every element of nums2, right? So let's take ith element of nums1. Let's say we are XORing ith element of nums1 with every element of nums2. So what we'll be getting? We'll be getting something like this. So we are XORing ith element of nums1, okay, with every element of nums2. First we XOR it with nums2 of 1, nums2 of 2, nums2 of 3, and so on and so forth, right? And we have to do this, like we have to finally XOR it with every possible I. Okay, so that's what we have to do. Now let's just solve the first expression. Let's say we have to solve this expression only. Now, as discussed, we can open the braces anytime. So we can just remove this braces altogether and group the elements just like what we want. Okay, so we can group all nums1 of I together. So we can form this one group with grouping all nums1 of I together, and one another group we can group all the nums2. So we can group all nums2 here. Okay, so what this first group will contain, will contain nums1 of I n2 number of times. What is n2? N2 is the length of the nums2 array. Basically, nums1 of I is occurring with every element of nums2, right? So how many nums1 of I will be there? N2. Now, similarly, in the second brace, you can put this nums2 of 1, nums2 of 2, nums2 of 3 in a second brace. Now, remember, we have to do this for all possible I. So basically, for every element of nums1 will be XORed n2 number of times, and finally this entire thing. So if you look at this, like this entire thing will be XORed with again two more expressions with different I. So here let's say I equals to 1. So here it is nums1 of nums1 of 1, nums1 of 1. Here it will be nums2 of 2, nums2 of 2, nums2 of 2, and this part will be exactly similar. And then finally nums2 of 3, nums2 of 3, and so on and so forth, right? Hope that makes sense. Now, what exactly you will be getting? you will be getting this expression in all the other expressions. So how many expressions you will get for this? Basically, this expression you get for single I. So there are total n1 number of i's, where n1 is the size of the first array. So this expression you'll be getting n1 number of times, and this expression you will be getting this expression for all I, and in every I there will be n2 number of each element. Okay, so finally you got this. Like, we can solve the problem using this approach as well, but let's just simplify. So what does this denote? This denote that just XOR every element of nums2, and whatever is the result, let's say r is the result, so just XOR r with like n1 number of times. So r XOR r XOR r XOR r with up to n1 number of times. Okay. Now we can do this, like we can solve this as well, but let's just simplify this a bit. So what the second, like the first expression would be nums1 of I, nums1 of nums1 I, and then XOR with nums1 of I plus 1, I plus 1, I plus 1, right? So now as like we have said that the XOR, we can break the brackets if the operation is XOR. So if as all the operation are XOR, we can simply break the braces and just group the elements as we like. So we can group all nums1 again, like nums1 of I, nums1 of I plus 1, nums1 of I plus 2, and so on and so forth. So finally we'll be getting nums1 of 1 2 3 4 and so on. And in the second braces again we will be getting nums1 of 1 2 3 4 again, and then again in the third base we will be getting the same thing. How many times we will get? We will be getting this as many times single nums is there. So how many times this single nums was there? N2 number of times, right? So we'll be getting this expression n2 number of times. So finally, what is the answer? XOR, like XOR every element of nums2. Let's say the result is R2. Then XOR R2 n1 number of times, and let's say the you XOR every element of nums1. Let's say result is R1. XOR R1 n2 number of times. So hope this solution makes sense. Let's look at the code. The code is very simple. We XOR every element of nums1 and nums2. All nums1 contain XOR of every element of nums1. All num2 contain XOR of every element of nums2. Now after that, you, as discussed, you will just XOR this n2 number of times and XOR this n1 number of times. So we have done that. So basically, with this for loop was not required. We can just check whether it is uh, odd or even, just to optimize. So let's say basically r XOR r is equals to 0, right? So if we just XOR r x number of times, we can just check whether x is odd or even. If it is odd, answer would be r. If it is even, answer would be 0, because all r will cancel each other. So but this for loop is again is not required, but we have done that. Now finally you will just XOR all of this in the variable result and return the answer. So hope this solution makes sense. If you have any doubts in the problem, please post them in the comment section below. If you like the video, give it a thumbs up and do subscribe to the channel if you haven't already. And I will see you in the next one. Thank you.